10.1, linear and nonlinear functions. A nonlinear function is a function that does not have a constant rate of change. Basically, what it's telling you is it doesn't have the slope. You cannot find the m value like you would in a linear function. Linear functions can be written in slope-intercept form. They have a constant rate of change. They have a constant rate of change with that slope there. We'll need to determine if functions are linear or nonlinear by looking at tables, graphs, equations. From all those, you should be able to determine if something is linear or not. From a table, the best way to do it is to go ahead and figure out that common difference for x and the common difference for y. The common difference for x is 2. Each of those are increasing by 2 every time. Find the common difference for y. Remember, when you write slope, it is the change in y over the change in x. Well, your x value is all changing by 2. If you look at your y value is not changing by the same amount. Therefore, this does not have a constant rate of change, meaning this is a non-linear function. The graph would not be a straight line. So it is nonlinear, and don't forget this piece that a lot of people do. Explain. Why is this nonlinear? Well, it does not have a constant rate of change, as mentioned, that we basically did by figuring out that common difference. So that would suffice for our explanation. Example 2, same approach. Figure out the common difference. Once you have that common difference, you can determine if it has that constant rate of change. Looking at this, it's increasing by 3 for x, increasing by 9. And if you had that constant rate of change, remember it is y over x. So your y value here is 9 over 3 listed above. We have, again, 9 over 3, 9 over 3. All of these would reduce to 3, which would be considered your slope. So this does have a constant rate of change. So this is a linear function. Linear function, constant rate of change, meaning that if we were to plot these points, this would form a straight line. Next couple examples are pretty easy to see looking at a graph. Remember, linear functions are straight lines. If you look at this line on the graph, it is not straight. Therefore, it is not linear. And again, it comes with an explanation. Why is this nonlinear? Well, graph is not straight. It has a curve to it. Example 4, easy to tell from a graph. This would be linear. Why is it linear? The graph is a straight line, therefore it can be written in slope-intercept form. So there would be our explanation. It is linear, can be written in slope-intercept form, meaning that the line is straight. Example 5, looking at the equation, determine whether y equals 5x squared plus 3 represents a linear or nonlinear function. Explain. Well, remember, linear functions are written in the form of y equals mx plus b, or f of x equals mx plus b. The biggest thing to note with the linear equation written in y equals mx plus b is that x has an exponent of 1. Okay, so if you look here, x is squared. When x is squared, cubed to the 4th power, basically anytime you start changing x, and x isn't a numerator, you're going to start to develop a different graph. So this is nonlinear, as mentioned. It can't be written in slope-intercept form, y equals mx plus b form. And the reason why it's not linear is because the x is squared, which is going to create a totally different graph. Example 6, determine whether y minus 4 equals 5x represents a linear or nonlinear function. Explain. This is actually a linear function. Why? Because you can write it in the form of slope-intercept form. Here's that original equation. Putting it in slope-intercept form, we would add 4 to both sides. When you add 4 to both sides, you have y equals 5x plus 4. That is in slope-intercept form. So this line would create a linear line. because it is written in slope-intercept form. Last example, clocks. Use the table below to determine whether or not the number of revolutions per hour that the second hand on the clock makes is a linear function of the number of hours that pass. So what we need to do is figure out that common difference again. And you notice here that all of these values, normally in a table this would be x and this would be y, all of these values are increasing by a positive 1. So they're all going up by 1. If you look at the next set, everything here is increasing, and they're all increasing by 60. So when you do your change in y over change in x, it's 60 over 1, 60 over 1. Everything is 60 over 1, meaning it has a constant rate of change. So this is linear. This will conclude 10.1 linear and nonlinear functions.